So at this point in your algebra career, we're somewhat limited with what we can do with algebraic expressions. So we can essentially just evaluate them or simplify them. So the first thing we're going to look at is topic 2, which is evaluating algebraic expressions. We have already done this before, okay? We did this quite a bit as we were working through our different sets of numbers. So I think we started doing this with maybe integers. So you saw some of this with integers. We saw it again with fractions and with decimals. Okay, so this should not be totally new. Okay. So as a definition, evaluating an expression is the process of replacing the variables with given values and then using the order of operations to simplify. Okay. And just in case you have forgotten the order of operations, again, we've done this a bunch. We did this in the first, I think, 4 chapters of the book. We did this with whole numbers, integers, fractions, and again, decimals. So the order of operations take care of everything inside grouping symbols first. So grouping symbols can be just standard parentheses. They could be like the brackets and braces. You could also technically have a radical, so like a square root could act as a grouping symbol. So like if inside the grouping symbol, like if inside the radical there was addition or subtraction or something, you could also potentially have absolute value bars. Now, for us, when we're starting to talk about algebra, it's largely just going to be parentheses. Okay, maybe some brackets, but that's it. Okay. So once you do that, you then evaluate all the expressions with exponents. After you get rid of parentheses and exponents, you deal with multiplication and division from left to right. And then you end with addition and subtraction again from left to right. Okay? So let's look at example 2. Example 2 says evaluate each expression for the given values, okay? So for part A, we have x squared minus 3x plus 4, and we want to evaluate for when x is negative 3. So what I do is I rewrite the entire problem. Anywhere I see an x, I replace it with a negative 3. And I will tell you this, with exponents in particular, always use parentheses. With multiplication, you're typically going to use parentheses, but with exponents, definitely use parentheses, okay? So we have x squared, which is negative 3 squared, minus 3 times x, which is negative 3, plus 4. So rewrite the problem. This is not a time to try to do like bunches of steps in your head. This is also a situation where you need to be especially careful with calculators. Yes, you're allowed to use calculators. No, the calculator cannot do all of the work for you. If you were to just put a naked number down for this, I would assume you cheated, honestly. I mean, that's just the harsh reality of it. You've got to show me your steps and your thought process. The calculator is merely a tool to do the side work for you. You still have to do the other work. Okay? So at this point, we do not have grouping symbols. Don't get confused with that. We do have parentheses, but it's not grouping symbols. For it to be grouping symbols inside the parentheses, you would have to have some operation. So addition, subtraction, multiplication, or division. We don't have that. We just have parentheses keeping a negative with a number, and that's really it. So these parentheses here really just indicate multiplication. But we do have an exponent. So we for sure need to take care of the exponent. Now, hopefully you remember from, goodness, probably chapter 2 where we were dealing with exponents where you had negative bases. So if you have a negative base, and we definitely do here, our base is negative 3. If the negative is in parentheses, which it is and it should be, then the exponent determines if this is going to be positive or negative. If we have an even exponent, this becomes positive. If we have an odd exponent, this becomes negative. So we have a negative in parentheses with an even exponent. This is for sure positive. So we could think of this as just positive 3 squared, which is 9. So do just one step at a time. So we took care of our exponents, we're done. Now we need to look at multiplication. And we definitely have multiplication. We have multiplication right here. Okay, so if you have any multiplication or division, you do those at the same time. We just have one multiplication. We have negative 3 times negative 3. Now remember, when you multiply two negatives, it becomes positive. So I'm going to rewrite this whole problem, and I'm going to replace negative 3 times negative 3 with positive 9. So I get 9 plus 9. Don't forget the plus 4 that was there to begin with. And now we're just dealing with addition, so we can just add from left to right. So 9 plus 9 is 18. 18 plus 4 is 22. Okay, so with the order of operations, take your time, don't try to rush it. So that kind of goes with evaluating these expressions. Take your time, don't try to rush it. Okay, now for part B, I forgot my part B. It's like I never notice my typos until I'm in the middle of the video and then I notice my typos. So we have negative 5x minus 3y divided by 3xy. And we want to evaluate this for when x is 2 and y is negative 5. So the first thing I'm going to do is I'm going to rewrite the entire expression. Anywhere I see an x, I'm going to replace it with a 2. Anywhere I see a y, I'm going to replace it with a negative 5. So this is equal to negative 5 times x, which is 2, minus 3 times y, which is negative 5 all over 3 times x, which is still 2, times y, which is still negative 5. Okay? And when it comes to these expressions that look like a fraction, you can do this just step by step, or you can simplify the numerator, simplify the denominator, and then divide. Kind of depends on your preference. Kind of also depends on your comfort skill. Like when you get really good at this, a lot of times we'll just kind of go step by step. Sometimes when we're maybe not as good at this or a little less confident, we'll do just the entire numerator and the entire denominator. So I think that's how I'm going to approach this one. So let's look at the numerator. So the numerator for this example is negative 5 times 2 minus 3 times negative 5. Okay, so we have basically two multiplications and then we have a subtraction. So let's do the multiplication. So first I have negative 5 times 2. So when you multiply two numbers with different signs, you're going to get a negative product. So we get negative 10. Then I've got negative 3 times negative 5. Well, when you multiply two negatives, it becomes positive. So negative 3 times negative 5 is plus 15. Now we're adding two numbers that have different signs. So that's where we find the difference in the positive and the negative. So we really technically subtract. So 15 minus 10 is 5. But do I have more positive or do I have more negative? Well, I have 10 negatives, but I have 15 positives. So that tells me this is going to be positive 5. So that's my numerator. Now for the denominator, we have 3 times 2 times negative 5. So we can just, it's all multiplication. So you can multiply 2 by 2, whatever. So I'm just going to multiply the first 2 and then multiply that by the negative 5. So 3 times 2 is 6. But I still need to multiply my 6 by negative 5. So 6 times negative 5, we're multiplying two numbers with different signs. That's going to become negative. So I get negative 30, and we now have to reduce, okay? So this isn't going to divide out evenly because the numerator is less than the denominator. So in a situation like this, just reduce your fraction. Now, if numbers end in 5 or 0, they're divisible by 5. So let's divide both of these by 5. Well, 5 divided by 5 is 1. 30 divided by 5 is 6, and then we have to take care of that negative, okay? So technically we had negative 30 divided by positive 5, which makes that a negative 6. But when you have a fraction that involves a negative, a lot of times we'll go ahead and just bring the negative to the front. So we would write it like this as just negative 1/6. Okay, so that is evaluating algebraic expressions. It's one of two main things that we're going to do. We're going to evaluate and then we're going to simplify. Not bad. You've done this several times. If you go back to those worksheets for chapters 2, 3, and 4, generally towards the end of a worksheet, we would talk about this. Okay, so we did this quite a bit in different worksheets. Okay, so really basic, nothing too crazy. The expressions that you may have to evaluate here might be a little bit more involved than what we did previously in the course, but nothing too crazy. All right, so next up we'll do the distributive property and then we'll end with simplifying algebraic expressions.